All right. Good morning, everybody. Welcome to today's class, Organic and Inorganic Chemistry 1. So, for those who were not able to join us last week, we've gone a bit far, but I hope you'll be able to catch up with us. Just to quickly summarize what we did yesterday, last week, so they can catch up with us. And I'll just use the first 5 minutes to summarize what we did, and then we can continue from there today. Please, this course, chemistry, is not just about listening to me. Okay, you need to write because I don't have a marker or a board where I need to be explaining certain things. So as I'm talking, you just be jotting things down. I'll try as much as possible to be slow. Those that attend the last class will know how we're able to flow. So we started with communicating chemistry and material chemistry. My hope is that by the end of today, we should have been done with material chemistry so that we can go to another aspect of the course outline for this course. So basically, communicating chemistry, we said the act of sharing information as far as science is concerned to the general public, okay, so that the public gets to know, okay, what chemistry is actually doing as far as the world or the society is concerned. So it covers the practice of disseminating chemical information, okay, informations that will help. And last week we tried to use the pandemic that's currently ongoing as an example, okay. So by the time they're sharing these things, they educate the public, on the best practices, okay, for maybe other consumption of food, drugs, and every other thing they're doing. So basically, communicating chemistry is about sharing information through journals, through news, and the rest of them, informing the general public of what's going on as far as the science world is concerned. And we said, why do we need to communicate science or chemistry for safety? Basically, our food, our medicines, okay, what is happening in the environment as far as the climate is concerned, climate change, global warming, clean water, ocean acidification. So basically for safety of mankind on planet Earth, especially as they try to adjust to the changing world or changing environment. And then we talked about it's also one of the reasons why we communicate chemistry is to give voice to science. By the time people hear about it and see the relevance of science, the young people that are, you know, making up their mind on the kind of profession to pursue can actually have interest in chemistry, okay, and build it as a career. And then to also inform and engage the public through public communication activities just to disseminate information. And then when this science or chemists communicate this information, so what motivates them? Said number one is the appreciation and the excitement that they get, okay, from educating the world, from changing the ignorance of the world. So chemists get their motivation for the fact that the public get to appreciate what they are doing as far as science is concerned. Yesterday, I was watching on Channels News. They held UK as a whole held 1 minute silence for healthcare workers that lost their life, okay, lives in trying to manage this COVID-19 pandemic. And after the 1 minute silence was held to them, they actually gave them a 1 minute applause for those of them that are still alive trying to fight and save humanity. Everybody, all the healthcare officers, all the healthcare workers came out, and everybody was just the whole nation was just clapping, applauding them. During the Easter celebration, the one that happened in Lagos, the governor of Lagos State had to celebrate Easter with them via, you know, Skype and the rest of them, and you could see the excitement. They're all dancing at the isolation centers and everything. So it makes them excited when they see that the public actually appreciates what they're doing, and then to also develop scientific procedures on consumptions and the rest of them. Talked about empowering the citizens and then encouraging workforce in development of chemistry. So that's it. What do chemistry gain? Number one is research. By passing these informations, they get to understand what the people are passing through, what their problems are, how they can make it better. Okay, so they get to know what the public wants and how they can provide it for them through science. Okay, that's what chemistry is from communicating chemistry. So that's that. So for you to have an effective chemistry communication, number one, set up communication goals. What do you want to communicate to the general public? Is it something that they will buy? Something that will accept? Something that will change their lives? Okay. So that's that. So you set communication goals. Identify yourself with your resources. The resources you're going to use to, disseminate this information. Then design the communication activity, and of course, take evaluation if what you're being communicated is being received by the audience and it's having efficacy, then assess, reflect, and follow up. So those are some of the things we talked about as far as communicating chemistry is concerned. Then we now dive into material chemistry, and we talked about there are two major objectives: um, to understand the various classes of chemical industries and specific raw materials they use, and then to understand the procedure for the production of some of the industrial products. So those are two objectives that we were able to create yesterday. And we said basically the raw materials that chemical industries use, okay, can be categorized into two: the inorganic materials, and we have the organic materials. And then we can see from the organic raw materials, we have the sodium chloride, the calcium triazocarbonate 4, the magnetite, and the coal. And of course, the product is as listed on that table. Okay, so these are the things that we looked at the other day. So that's for the inorganic. Okay, then for the organic raw materials, we said they are basically from wood, from natural gas, from animal cells, from vegetable oil, and then of course the crude oil. We took our time last week to actually explain them one after the other. Okay, so that's where okay, this is where we stopped last week: the natural sources and the uses of these industrial raw materials. So we said the sources where you can get these raw materials for industrial use are from the earth, the air, the water, and the agricultural product. So last week we talked about we picked up the earth and the water because they are both in the same stratosphere. Okay, so we're going to continue from there. Okay, from where we started, so we're able to talk about the earth, what and what we get from the earth, the water. Like for example, the water, we talked about the brine, which is sodium chloride, and what their uses, how they are being um, electrolyzed. Okay, I think in the next course we're going to be doing it. We're talking about electrochemistry. We'll actually deal with electrolysis and the rest of them. So, so we've already completed the earth and the water. So where we are starting from today is the air. So we're going to look at the air as a source of industrial raw material. Okay, so if you're ready, I am ready. So basically, we understand that the air is composed of nitrogen, oxygen, and noble gases. Okay, the air consists of nitrogen, oxygen, and noble gases. Okay, all these they exist on their own in the atmosphere. We also have the neon, the xenon, the argon, and the krypton. These are trace elements that you find in the atmosphere. Okay, but the major composition of the atmosphere is the nitrogen, the oxygen, and the carbon dioxide. Those are the major ones. Every other one, the noble gases, the neon, xenon, argon, and krypton, they are all found in trace minute elements. Okay. Now, these mixtures, for you to be able to separate these mixtures and get the pure element, it needs to undergo what referred to as fractional distillation of liquefied air. So when you need to collect this air, maybe in a tube, for example, for you to separate the various elements that make up the air composition, you need to engage, or you need to subject that air to fractional distillation of liquefied air. Okay, so as soon as you do that, you'll be able to get these various elements that I told you: the nitrogen, the oxygen, and trace elements that you have there. Okay, so that's like an introduction for you to understand. I repeat myself again for clarity. I said the air is composed of nitrogen, oxygen, and some trace elements. All these exist on their own. Now, for you to be able to capture them, okay, they have to first of all be liquefied, okay, and then through fractional distillation, you'll be able to separate each of these elements one after the other. So let's look at these raw materials now that we can get from the air, which is used for production, okay, in our industries. The first there is the nitrogen. You know, studies have proven or have shown us that nitrogen is the major element to have in the atmosphere. Almost 78% of the atmosphere is nitrogen. Okay, then the oxygen is about 21. Yes, and then the remaining one takes 1% of the remaining atmosphere. So nitrogen takes almost the over 70% of the atmosphere. That is the nitrogen. Now, what are the uses of nitrogen as far as an industrial raw material? Let's look at the uses of nitrogen as industrial raw material. Remember, we said we're looking at the air as a natural source of these raw materials that are used in the industry. Now, we've identified nitrogen as one of those raw materials that industry uses. And we said you can obtain nitrogen from what? A fractional distillation of liquefied air. So we're looking at the uses of nitrogen. What are the uses of nitrogen? Number one, nitrogen is used to manufacture ammonia. So from nitrogen, you get ammonia. Nitrogen is used in the manufacture of ammonia. And how do you get ammonia from nitrogen? It is through Haber process, Haber, through Haber process. So once you subject nitrogen to Haber process, one of the byproducts is ammonia. Okay? So nitrogen is used to manufacture ammonia by a Haber process. Okay? Now this ammonia is used in producing. Now this ammonia that one of the byproducts of this Haber process of nitrogen is used to produce trioxonitrate 5 acid and ammonium chloride. I take it again. I said nitrogen is manufactured, ammonia is manufactured from nitrogen by a Haber process. Now this ammonia that has been manufactured through Haber process is used in producing trioxonitrate 5 acid. It is used to produce trioxonitrate 5 acid and ammonium chloride. Okay, trioxonitrate 5 acid and ammonium chloride. Now these two compounds are used in the production of fertilizers. The ammonium chloride and the trioxonitrate 4 acid are used in the production of fertilizers. They are used in the production of explosives. They are used in the production of plastic wares and dry cell batteries. So you see the use of nitrogen as a raw material. So through Haber process, you get ammonia from nitrogen. And this ammonia is used to produce trioxonitrate 5 acid and ammonium chloride, which is used to produce fertilizers, explosives, plastic wares, and dry cell batteries. So nitrogen is a very important raw material used in industries. So that is that for nitrogen. So we're moving on to the second one, oxygen. Okay, which is the second major element that you find in the atmosphere, which can also be gotten through the fractional distillation of the liquefied air that I talked about earlier. Okay. Now, oxygen, of course, we know it as O2, is a supporter of life. Okay, it also supports combustion. Combustion means burning. So the major use of this oxygen it can be used basically in welding. So if oxygen supports combustion, you see the use of oxygen during welding. Okay, so oxygen is used for what? For welding, basically welding. Did you get that? Okay, so that's the major use of oxygen. Oxygen also supports life, so you can condense or compress this oxygen, okay, into cylinders, okay, into tube ventilators to support life, okay. Especially like we go to the hospitals, you see, people on ventilators and life support machines. So they are being supplied of oxygen artificially because they cannot. So that's also another use, industrial use of oxygen. Then for the noble gases that we mentioned, they are basically used for filing electric bulbs. Okay, that fillings you have inside the electric bulb is actually those noble gases, the protein and the xenon. That's what they use in making that. So that is the use of the noble gases, the oxygen, nitrogen, as far as the air is concerned. So we have mentioned air as a natural source and the elements that are used in the as industrial raw materials, which is the nitrogen, which is used to manufacture ammonia, and ammonia is used to produce triazonitrate 5 and ammonium chloride, which is used to produce fertilizers, explosives, plastics, wares, and dry cell battery. Oxygen, like we said, is used for welding, used to support life. Okay, then the trace elements, which are the noble gases, are used for filling electric bulbs. So those are the industrial uses of raw materials gotten from the air. So I've done justice to the earth, the air, and the water. So the last one we have there is agricultural products. Agricultural products. So what are the uses of these agricultural products as a source of raw material, industrial raw material? Now understand that most of the plant and animal raw materials are organic in origin. Okay, the raw materials gotten from plants and animals are basically organic raw materials. Okay, like the vegetable oil, such as the castor oil, the olive oil, the palm oil, the palm kernel oil, coconut oil, groundnut oil. All these oil I mentioned, they are all organic raw materials, okay, gotten from plants and animals, and they play a vital role in the manufacture or production of soap and margarine. That's margarine. I take it again. I said most plants and animal raw materials, the raw materials of gotten from most plants and animals are organic in nature. Okay, for example, the vegetable oil is an organic raw material from agricultural products and include the castor oil, the olive oil, the palm oil, the palm kernel oil, the coconut oil, the groundnut oil. All these are used for the production of soap and margarine in the industries. So if you've got like 2 or 3 of those oil I talked about, okay, it's okay. But basically, understand that they're used for production of soap and margarine. So that's that for the vegetable oil and the uses. Okay. Of course, we also know that these vegetable oils also are used for cooking. Okay. Like the vegetable oil, what they call it now, the coconut oil, groundnut oil. Okay. They also use palm oil. Sorry, also used for cooking. I remember those days my grandma usually used palm kernel oil to make soap, local soap, and it can foam. I've not seen any soap that foams, that leathers like those palm kernel, those soap made from raw organic raw materials. Then other raw materials gotten from agricultural products include sorghum, 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 We have sugar, okay, from sugar cane, another plant produce. We have barley, barley. Barley is also under agricultural raw material. We have millet. Now let me explain this, why they are also industrial raw materials. The sorghum, the sugar, the barley, the millet. Some of us already know their uses. Now, when these products that I talked about, once they are subjected to fermentation, once they ferment, you get a lot of products from it. Like sugar, what they call now, uproot cassava root, peel it, and then just put it, pour water inside and leave it. After a few days, 3 to 4 days, it ferments, okay, with the presence of some bacteria in the atmosphere and the enzymes and the rest of them. What happens? You get ethanol, okay, from it. So basically, fermentation of these agricultural products, okay, gets us ethanol. Okay, you get what I'm trying to say? So during fermentation, when these products I talked about, once they are fermented, it produces ethanol. Okay, now this ethanol are used to produce alcoholic drinks. After processes I've gone through, they used to produce alcoholic drinks like your beer. Beer basically from barley, beer and malt, get it from barley, from millets and sorghum. Yes, so they are used to produce alcoholic drinks. This ethanol produced from fermentation are also used as industrial solvents. So they used to produce industrial solvents. They also used to produce cotton fiber, that's the cellulose. They also used to produce cotton fiber. Okay, you also get natural rubber, which is the latex from this rubber plant, from the skin. You see this, the bark of the tree. You know, there's a way of those timber farmers and the rest of them, they just create a line, mark lines, and then they tap. Okay, before you know it, those white substances that comes out from it, they are being collected, which is used to actually produce plastics and rubbers. Now, from these millets and all these agricultural products I talked about, they can also be used to produce dyes, gum, and perfume. Okay, so this natural rubber, which is the latex, are used to produce dyes, gums, plastics, and perfumes, and other fermented products. You know, perfume, every perfume has an atom of alcohol inside. It is made from this ethanol. So that is the industrial uses of industrial raw materials as far as agricultural products is concerned. So what I just said, I said that basically we're looking at it in two categories as far as agricultural source is concerned: the vegetable oil and the plant products. The vegetable oil, like the castor oil and the rest of them, we said they are used to produce soup and margarine. Then while the sorghum, sugar, barley, millet, the rest of them, once they are fermented, they produce ethanol. And then from ethanol can produce a whole lot of things. The alcoholic drinks, the perfumes, the dyes, then the latex also that you get from the back of rubber plants, of rubber trees, are also used to produce gums and the rest of them. So that is the uses of industrial raw material as far as the agricultural product is concerned. Okay, so yeah, I think I've explained this: nitrogen, oxygen, and noble gases. Okay, that was where we started from. Then, of course, the raw material, which I just explained now: the vegetable oils, the sorghum, the sugar, the barley, and the millet. Once they're fermented, they produce, they are used to produce alcoholic drinks, the rest of them. So let's look at the divisions of chemical industry. Okay, division of chemical industries. We can divide the chemical industries into 11, 11 major distinct. We have the heavy chemical industries, we have the fine chemical industries, we have the fertilizer industries, we have the plastic industries, we have the methodological industries, we have the ceramic industries, the paint industry, the cosmetic industries, the soap and detergent industries, and of course the cement industries. Those are the divisions of chemical industries. Okay, I hope we got that. Now, basically, now these chemical industries, let me explain something now before we list all these things I've talked about. Now, these industries, because somebody may ask, how did you divide them? What is the basis for this division of chemical industries? Understand that there's no particular criteria for dividing chemical industries. But what I just listed to you, the basis I used for dividing these chemical industries is based on the raw material that is used, okay, or the raw material that is utilized, or the product of some of these major divisions. So you can use those three categories to divide in chemical industries into different divisions, either because you divide them based on the raw materials they use and utilize and the products of some of these industries. Okay, so that can be your basis for actually dividing them into different listing. Okay, but basically somebody has opined that there are basically two divisions of chemical industry, which is the heavy chemical industry and we have the fine chemical industry. That's under classification or division according to another researcher or the chemist. Okay, he basically divided chemical industries into heavy chemical industries and fine chemical industries. What's the basis for this division? He said for the heavy chemical industries, they deal on production of chemicals in large quantity. Okay, so when you produce chemicals in large quantity, you're simply referred to as a heavy chemical industry. Example, let's look at these industries now that we listed. The paint industry can be categorized under heavy chemical industry. Okay, the fertilizer industry, the cement industry, the soap and detergent industries. Okay, this can be categorized as a heavy chemical industries because they deal on the production of chemicals in large quantity. Okay, now for the fine chemical industries, chemicals are produced in smaller quantity compared to the heavy chemicals. But one thing about this fine chemical industries is that their products are purer in form and they are also very costly. Let me take it again. I said for fine chemical industries, chemicals that are actually produced in smaller quantity compared to the heavy chemical industries. But their products are usually very, very pure, very, very fine, highly valuable. And because they are highly valuable and very fine, they're usually very costly. Okay. Example, we have the reagent industries, the dye industries, like the rest of them. So basically, these are the divisions of chemical industries: the fertilizer industry, the plastic industries, the methodological industries, the food and beverages, pharmaceutical industry. I don't think I listed pharmaceutical industry there. So it's also part, okay, of chemical industry. Glass industry is also another division of chemical industry. The food and beverages. So there are a lot. There are a lot of divisions of chemical industries. So what I said, the basis for dividing them into different divisions is based on the raw material that they use or utilize, and also their end product, what they produce at the end of the day. All right. So that is that for the division of chemical industries. Okay. So let's proceed to the next slide. Factors to consider when setting a chemical industry. In the next 5 minutes that I have to complete this class, we'll be able to round up this course. So that one will come again the next time. Start from introduction to electrochemistry. So what are the factors to consider when citing a chemical industry? Availability of raw material. Your raw material cannot be in Sokoto and you're citing your industry in Lagos. Imagine the cost of transporting the raw materials from Sokoto to Lagos. So when you're citing a chemical industry, cite it, a place that has proximity with the raw material, so that you can use it anytime you want. The cost of transportation will not be too much. Okay, imagine you have a production to do about, let's say, 10 tons, and the customer already paid for it. I promised the customer is going to get it in 10 days, thereabout. They start having challenges on the road, transporting it from Sokoto to Lagos. So you need to put that in consideration: availability of raw materials, availability of labor force, workers. Okay, are they available? You also put that in consideration when citing your chemical industry. Transportation costs, like I said, transporting not just the raw material, also the finished product to the market, to the retailers and the wholesalers. We also consider that. What most industries have done as far as this is concerned is that they just contract it out to marketing companies. So this is just to produce. How it's being transported is not the problem. This marketing company comes, then they pick, let's say, 5,000 cartons of that product, and they pay the producer the cost of the 5,000 cartons, and they go, and then you know how they are going to get the products to their market and the rest of them. So that's that. You need to also consider that. Closeness to market, just like I said, proximity to market after your product is ready. Don't site it far away from the company, from the market, except you have marketers, okay, who just come and pick it, so they don't want to bear the cost of the transportation. Okay, and of course, power and fuel supply is also another thing that you need to consider when citing an industry. Okay, that's why in abroad they have industrialized areas. They basically set up that particular place for industries. So if you want to cite your industry, just go there, because the kind of power they give them there is quite high. Okay, because that they actually make use of it. But in Nigeria, we have such, we have to make provisions for power, okay, of fuel supply. So proximity to these two things should also be considered when setting it up. Closeness to the river water for cooling effect, in case if your industry requires water. Okay, maybe HVAC, for example, you have equipment and installations that require HVAC. HVAC means heating, ventilation, and AC. So it means you need to site your industry, your chemical industry, close to the river, or where you can always get water. In the south side is not a problem. Most industries, they have a borehole where they can easily get. Okay, Lagos too, all those water areas is not a problem. So imagine if you're in the north, it becomes a problem. So those are the things. Do I have closeness to river, water? Also do that. Telecommunication facility, okay, is also another thing you need to consider, because you need to disseminate information. You need to reach out to your customers. You need to reach out to the raw major, those who are in charge of the raw material and everything. So do you have network there? We also consider that. Then cooperation with the community, you must be their major stakeholders. If you don't have a mutual relationship with them, they will frustrate your company. Okay, they can come and vandalizing your installations and equipment and the rest of them. So there must be a cooperation within the community. And how do you do that? Make sure that there's a particular percentage, okay, of your workers that will come from that community. That's the best way to solve that particular problem. So those are the things that you need to consider as far as citing your chemical industry is concerned. The effect of chemicals in the community. Number one, of chemical industry. Sorry, it's a typo error. Effect of chemical industries in the community. So the community where these industries are being cited, what effect does it bring to the community? It provides employment opportunity, like I told you. It necessitates migration. People start moving from different locations into the community because they want to come and work there. Okay, and then also increases the purchasing power of the people. So by the time they're getting fully employed, many of them will become satisfied, to some extent and be able to now provide for themselves and for their family. All right, so this concludes um, material chemistry, communicating chemistry and material chemistry. So when we come next week, we will start from introduction to electrochemistry. That's what we're going to be starting from next week. I hope we all enjoyed ourselves, and I'll see you guys next week.